Hello, welcome to your video lecture on water pollution. We're going to kick off this time with vocab, so pause me, apologies for the text. Pause this video to be able to take your vocabulary. Okay? Alright, here's my bell ringer question. So this can go in the bell ringer section of your videos. Again, try to upload a picture of the bell ringer section as well as your notes, just so that I know we're kind of checking our knowledge and seeing how much you know before we actually do the lecture. So here's my question for you. You can put 1, 2, 3, and I think there's 4 pictures. You can write just yes or no. Would you swim in this water right here? What do you think? Looks pretty clear to me. It's so clear it doesn't even look like the boat is actually sitting on anything. It almost looks like if it's floating if you're not paying enough attention. What about this one? Would you swim in this water? Or how about this one? Would you swim in this water? Alright, and here's my last one. Would you swim in this water? What do you think? That guy's doing it. Would you do it? Alright. So what's the difference between these pictures? Like, what's the difference between the pictures of water? What's different about here and here and here? What do we see? I see garbage in this water. I see particles of even just organic matter like wood in there. I see a lot of plastic. I see some plants mixed up with the garbage. Here I see a shiny substance on the water. That's usually indicating either oil or gasoline, by the way. I see lots and lots of algae. Now, some algae in a system is pretty good, you're going to learn, but if we have a ton of algae, it actually can create something called, does a process called eutrophication. Hard word, but we're going to learn about that in another lecture. But this is, maybe a normal amount of algae. Would you swim in this? Here we don't see any of that trash. I don't see anything that's shiny like that, indicating oil or gasoline. And here I can't see anything. Maybe that's a sea life right there. Can't tell. Maybe it's a rock. But no garbage, no man-made issues. Okay, today we're going to talk all about how humans are impacting the hydrosphere. Actually, that's what we're going to talk about for the next couple of days. But I have a poem for you to kick it off. The stream where I played is what it's called. I played in this stream as a child when the ravines seemed so endless and wild. The water was clear and smelled so clean. It was so long ago that it seemed like a dream. Now this stream is too dirty for my child. The water is scummy and smells vile. The place where I played seems so foul and decayed, and I shed the first tear as the dream starts to fade. So, what's happening in this poem? What are you seeing? What do you learn? What happened? What is the author describing? The author once played in a stream that was so endless and wild and clean and clear, but now it seems like the author has grown up and has a child of their own, but the stream is too dirty for the child to swim in. It smells bad. It's got stuff in it that's gross, scummy. It's foul, decayed, and the author's sad as their dream starts to fade, or the childhood that they once had, the wonderful, pretty, beautiful, nature-filled childhood, is not a possibility here at the stream for this child. So one of the big things that we're going to talk about in this unit is how we are really and quickly impacting the water quality all around us. Okay? Today we're going to talk about some pollution. Water pollution is the topic of this video lecture. So what is water pollution? We define it as the addition of harmful chemicals to natural water Now, these chemicals could be something like the Gen X that we know came from DuPont up the Cape Fear River that causes cancer down in whoever drinks it downstream, which, by the way, you're downstream, so is Wilmington and even the Atlantic Ocean. Or it could be something as simple as adding nitrogen to a body of water. And now nitrogen is naturally found, nitrogen is naturally found in the water, so is phosphorus. But what we're going to learn later on is that when we have too much of the natural chemical into the water, it can actually have some devastating effects on the ecosystem. Now, some sources of pollution in the water in the U.S., a lot of them come from industrial waste, so like factories like that DuPont secreting chemicals. Some of them come off with the rainwater as the rain comes into, because remember when we talked about river basins, we talked about their areas that drain into a river. So anything that runoff water passes and picks up is going to be eventually carried on and put into the river, whether that be big trash that we can see or even just chemicals. So a lot of the fields that are treated with fertilizers, that nitrogen and phosphorus that I was just talking about, put too much on, and it actually can, because of the rain, can come into our water systems wreaking havoc. And then also we can have runoff from areas that have been mined, so any of those chemicals that were used in the mining process, or even just the sediments that are now loose from the mining process, can be carried on into the river as well. And you can have everyday, I say everyday, you can have just human-made pollution like trash. If you have a plastic bag out, if we remember our turtle talk, if you have a plastic bag that has been thrown into the street, the wind can carry it into the river where it is eventually brought down to the ocean. They told us that every trash is only 6 points away from the ocean, so all it has to do is make it into a storm drain, which will eventually enter into a river or the ocean itself. Not a lot of things preventing our trash from entering the hydrosphere, huh? We have two different types of pollutions, the way we categorize them. The first is called a point source pollution, and this is a contamination that enters the environment through a specific or traceable means, which means that we can tell exactly where the pollution in the river downstream has come from. So this is very specific. That traceable means that we can point to the place where it comes from. Some things like sewer pipe, plant pipes are examples, as well as coal ash ponds. But another one, and a very applicable one for your life, again, is that the chemical plant up near Fayette, in between here and Fayetteville, that has dumped chemicals into the Cape Fear, and now we can trace them all the way back down the river to Wilmington. That is, they found them in Wilmington. Some researcher found them in Wilmington and then traced it all the way back to that factory, so we can tell exactly where it came from and who put it there. That's a point source pollution. Think you can point your finger at it. In contrast, we have non-point source pollutions as well, and these don't have a specific point of origin, or if they do, we cannot tell exactly where they came from. So this can be from land runoff, so like that fertilizer that we were talking about. Precipitation can cause this, the reason why we are getting the pollutants, I said that wrong, the reason why we're getting the pollutants in the system is because we have land runoff, so just the water passing through the land. We can have heavy precipitation, or sometimes even just normal precipitation can pull with it those dangerous chemicals into the hydrosphere. It could be atmospheric deposition. Remember how we talked about where the ocean meets the air, there is a transfer of carbon dioxide into the water. It becomes carbonic acid, which is a pollutant in the hydrosphere. It can come from drainage or seepage as well. And don't think that we are just affecting the water that's on the surface. We learned about in our past unit that water is underneath the surface as well in aquifers, and we can also pollute those as well. But it's much harder to trace pollutants in our underground water because we can't see it than it is in our surface water areas like rivers or lakes. Some examples of non-point source pollution are just the stormwater runoff. Arsenic from mining. Arsenic is a common chemical used in the mining process. If you know about poisonings or maybe watch investigative shows, arsenic is a very deadly poison to humans and other organisms. Sediments, again, from the land runoff, so even just too much loose dirt into a river system is bad for it. Remember, runoff is any water that doesn't infiltrate into the ground, so think like your puddles outside that are moving or your little streams, that's runoff. Now we're going to talking about the impacts of humans on the hydrosphere can get a little depressing, but I want you to know that there are ways that we can reduce point source and non-point solutions and pollutions and how we can reduce our impact altogether. So one of the goals of this class not only is to teach you all about the different systems and how we're affecting them, but to give you the tools that you need to be environmentally conscious citizens. So how can you change your life so that you are not impacting the world in a negative way as much as previous generations? So here's how you can help. You can use fertilizers and pesticides according to the package directions. Don't put on too much, put on just as much as the directions say. You can have your septic system inspected every 2 to 3 years. So think about this for a second. A septic system is basically a giant underground holding tank for your waste, your poop and pee. Think about if that breaks, and then all of that fecal matter is seeping into potentially groundwater. So get that inspected. Make sure everything's a-okay every 2 to 3 years when you're an adult and have your own house. Conserve sprinkler water, so don't run your sprinklers unless you have to, or don't run them at all. But that's a debatable opinion. Never dump anything down a storm drain. So storm drains lead to water sources, freshwater sources like rivers and lakes, or even the ocean if you're close enough. Pick up after your pets. Pet waste left on the ground can spread E. coli, roundworms, and salmonella. You don't want any of that in your drinking water. Pick it up, put it in the trash can where it belongs. Some other things you can do: wash your car over the grass and not on the cement. That way that the soap is filtered through the ground instead of going straight to the storm drain. You can make sure that you are conscious about the water you're using. So maybe don't use as much water in the shower, or when you're washing your dishes, turn off the water in between washes so you're not wasting it and that's not going into the system. But that's a little bit of another topic. And again, we're going to talk about how those different pollutions go through the water supply. So pollutants move through a water supply along with the water. So basically, whatever the water picks up is going to be pulled down into the system. Water moves things. Think of boats. Think of your pollutants as little boats going down the river in a not so cool way. As they move down the river, they're going to go where the river goes. If the river ends in the ocean, that's where they're going to go. If it ends in a lake, that's where it's going to go. And you're going to have a buildup of those pollutants and have more concentrated areas of that. If it makes it to the ocean, yeah, it might dilute out and not be such a big deal, but why put the pollutant there in the first place? Especially if it's somewhere like this sound right here, that Outer Banks are actually trapping in those pollutants, so it's harder for the pollutants there to dissipate into the ocean. Pollution effects on water quality. So communities across the country are starting to face challenges in maintaining healthy and affordable water supplies. My friend Tori just lives in Grace Creek, and actually she can't drink her water supply. It is polluted, so the water that comes out of her faucet is too polluted for her and her husband and dog to even drink. They deliver water for them, so that's not good. An increase in size of populations means that there's less water per person. We're going to talk about that in another lecture, especially because we're running out of time. We actually might have to do another lecture. So hold tight. There's going to be about 6 more minutes of lecture to watch. We stopped right here.